Hi, everyone. Can you hear me okay? Yeah, so welcome, guys. Welcome to Git Panic and how to avoid it. Please give a warm applause to the organizers of HackConf for giving a great conference and making this happen for us all. Yeah, thanks a lot. Yeah, so an alternative title for my talk could have been Cool Tricks You Would Learn If You Actually Read the Manual. In a short disclaimer, I expect that you have some basic knowledge of Git, and as I saw by the hands up, you probably have. Even you probably know most of the stuff that I'm going to tell you today, but anyway. A couple words about me. My name is Mihail Mikov. I'm a full-stack engineer at SkyScanner, and I'm a hobby juggler. So if you saw me outside, throwing some balls, that's what I do in my spare time. I'm going to talk about Git today, and Git is hard, so learning Git can be challenging. I know that you probably have your own, stories when you tried to do something and it didn't quite work. So what are some of the symptoms that are very common for when you're trying to do something with Git? So basically you're trying to do something, but you're not sure. So uncertainty is one of the biggest things that prevents people from doing Git well. Some of the symptoms that you might experience are, if you're using Git only for the GUI, that's not a good thing. You're putting a middleman between yourself and Git, and you're not learning Git, you're learning the GUI. So that's not the best possible thing. If you have a unstructured or a messy history, that prevents you from actually being able to trace how your project is developing, what's happening, why, and tracking the project is actually what Git should be supposed to do. If you have a complicated workflow, or if your workflow blocks your work, that's pretty bad because then you're losing time, you're losing effort, you get frustrated, communication breaks down, and it's not good. Kind of big bad one is if you fix Git by cloning to a fresh new repo, that means that you feel totally unable to handle the situation and you just need to start over. That's pretty bad. Some more symptoms would be if you have push races, which means basically that developers are trying to push their code first so that they don't have to deal with the conflicts. And that leads to a lot of animosity inside the team. Pretty bad it would be if you lost your local changes, so you're doing something, you're coding, you try to stage that or you try to commit that and somehow you lose your changes. That's awful. And maybe the worst one would be if you start losing remote commits. So you push something, you force push, you delete the branch history, you delete something that somebody else pushed just a minute ago, and for some reason we can't recover that anymore, so that's horrible. So how do we fix this? How do we fix our Git? Well, you have a couple of bad options, and your first bad option is to ignore it. Well, I don't have my picture here. Sorry for that. Your second bad option would be to just panic, which I don't recommend. And the solution, of course, is don't panic, because we have some pure vegan homeopathic solutions for you. The first one is read the manual. So if you are in doubt, if you're not certain how to use a certain command, or you just forgot, I usually reread the Git manual once a couple of months, just so that I know that changes that they made, or I forgot that some command takes a cool option that I can use to make my workflow better. Using the console is a great way to improve your Git skills. Basically, you are right there using the primitives that the creators of Git intended you to use, and you get the most pure experience, and you get to understand how Git works, and you can dive in, and you can do a lot more complicated stuff, of course. Check your status and history often. Meaning that you should know where in your project history and where in the state of your development you are. The same way you keep in your head the state of your code, in the same way you have to keep the state of your repository in your head while you're developing, so that you know what's happening and you can track and you can see what everybody's doing. You should fetch your remotes often, which means that way you can keep up with what work are the other people on your team actually doing, and you can anticipate something, and you can resolve merge requests or merge conflicts much more easily and much earlier. And push your work in progress often. So if you want to be able to fetch other people's work, then they should be pushing it. And if you want them to be able to get your work, you should be pushing your work as often as you can. Just mark it as a work in progress so they know that it's not ready yet, but you're giving everybody a chance to actually see what you're doing and what your current line of thinking is. Some more solutions. Follow a commit message format. This is paramount when you work in a team. If you want your history to be understandable, if you want to be able to trace what's being done, what are you doing, what everybody's working on, then following a commit message format is very important. My advice here is it doesn't matter what the format is, as long as it's consistent within a team. So consistency is the best way to make a structured history. Name your remotes and branches meaningfully. That helps a lot if you're working with a lot of remotes. If you have a lot of branches, names like A or stuff or something like that just doesn't do it, or even origin, like the default name of the default remote that you get. It's not meaningful if you have like 5 remotes. Which one was the origin? Where am I pushing to? What's happening here? So meaningful names help you take off some mental burden that you might have with that. And make Git help you. Git has a lot of features and a lot of functionality that you can use to make your workflow better. You can use it to your advantage, so you don't have to be scared. You have to be confident and just learn those things, such as alias, tags, hooks, and command line options. And we'll basically focus on command line options today the most. Just a couple of like cool things that you might not know. So a couple words just about commands. You probably all know this, but this is the structure of a command. You have a command name, you have options passed in with minus minus or just minus, and you have arguments, and each command takes different arguments and options. And there are 2 categories of command types. You have local commands and remote commands. So Git doesn't do anything on the network if you don't tell it to explicitly do something on the network. So there are just a couple of remote commands. And the other distinction between the type of commands is plumbing versus porcelain, which means plumbing commands are basically the low-level internal Git commands that Git uses internally, and the porcelain commands are the high-level commands that we use every day to interact with Git. So basically, that's just a couple words about distinction. My favorite part about working with Git is seeing the project history. Looking at the project history, and here we are looking at the git log command. It takes a bunch of options. So in the screenshot below, you can see the output of the first command that I've put there. It gives you a very concise but very detailed view of your history. So it's very easy to see what's being done, what's the state, which part of the work is where, and you can orient yourself. You can actually do a lot of git log. It allows you to filter your log by, let's say, the author of the commit, and you can put a regular expression there. It also allows you to filter by date. It allows you to filter by refs, so you can give branches or commits or even ranges, as I have on the third line here with the triple dot, and we'll see what that means in a second. And the last line shows that you can use a git log to display either a stat, which displays a couple of lines showing which files were changed in each commit, or you can display -p, which gives you the full patch of the commit, so you can see all the changes that were made in this commit, and that can be very useful sometimes. So a lot of options for viewing the history. So what are commit ranges? Basically, if you put 2 commits or 2 refs and you have 2 dots between them, that means that Git will give you everything on the B side, nothing on the A side, and none of the shared ancestry. If you put a triple dot, so A triple dot B, that means I'll get everything on the A side, everything on the B side, but nothing of the shared ancestry. And you can see that's pretty cool. You can either see, hey, what does some other guy's branch introduce, what changes does it introduce, or what are the differences between my branch and master because I was on vacation and I haven't pulled in like a week or two weeks. So pretty useful. You can also check out your branch history. Git reflog allows you to provide a branch name, and it prints which commits your branch pointed to historically. So this is a lineage of the commits that your branch pointed to. And it's, again, very useful. You can go back and say, hey, what was I working on yesterday? What was I working on last week? And you can check that, and you can see that in the Git reflog. There are many ways to reference commits, and they can be kind of confusing most of the time. So here on the first line, we see that we have a caret reference, a caret master, and that means exclude the given commit and know its ancestry from the output of the log, let's say. But if you put the caret at the end of the ref, so you say caret, master caret, then that means give me the ancestor of that commit, give me the parent or the grandparent of that commit. And if you want to get the grandparent, let's say, you either put double tilde in there, double caret in there, or you use tilde with the number indicating the ancestry. But if you put a tick or a colon and a number, you would not get the ancestor, you would get the second parent. So I've put a little picture there. I don't know how visible it is, but basically if we have here the M commit is a merge between the C and the Z commits, then the Z commit is, let's say, the first parent of M, so we can say M caret 1, and the C commit is the second parent of M, which is M caret 2. And you can reference these commits by many ways. For example, the Z commit is at the same time Z tilde 2, and it's M caret 1 tilde 2. So you can reference that depending from where you start your search within the history. And there are actually more. You can reference commits through the reflog. So here we say a ref, let's say master, and we say at, and in curly braces we give a number. That would go to the reflog of your branch, find the entry number, the second entry, and give you the commit that points to. So you can, and another way to query the reflog in this way would be to use a date. So you can say, hey, where was my master branch pointed at 5 days ago or 10 minutes ago or something like that. So that's pretty useful, and you can discover and you can walk your history in that way. You can also, Git also tracks the file history for you. So using git blame, here we have a small screenshot of that. Git blame allows you to see the file history. So line by line, it says which was the last commit that changed this particular line in the code. If that's one way to view the file history. Another way to view the file history would be using git log with the -p option. And if you put -- and then the file name, it would actually give you a list of all the commits that changed that file and the full patch of the change that they made to that file. So depending on what you're looking for, these are two great ways to see how this file changed, how it evolved over time. So adding something, when we're using Git, we use git add a lot, and we want to add stuff to our next commit. And there is a cool option, the -p option, when you use it with git add. It allows you to stage individual lines of code or individual hunks of code to your next commit. So here I say git add p, and for every change that I made in my working tree, it would ask me, do you want to put this in your next commit? Do you want to put this in your next commit? And you can actually select kind of individual lines that you want to put into your next commit. And that prevents you from adding debugging statements, adding some experimental code. So it's like a proofreading just before you commit. It's pretty useful. The opposite of that, you can give the -P option to reset, and that would mean, do you want to remove that from the index? Do you want to unstage the changes? So by accident, I staged a whole file, and now I have a debugger line in there, and I want to remove it. I can do git reset -P, and it would ask me, do you want to remove this, or this, or this? And I will select the one I want to remove, and that's pretty useful as well. Again, -P, very versatile, a lot of commands use it. So checkout -P would actually delete the code you have in your working tree. So you change something, but you decide that that's not a good change, you don't want to keep that. So you can say git checkout -P, and you can delete the working tree things and take out the things that were in your last commit, let's say. Here in the picture, you can see that Git is doing you a slight disservice because the colors are flipped from what you might expect. So here we see that the tree line, the work tree lines seem to be added, and the commit line seems to be removed. But what this command would do would actually flip them. So it would put the committed lines back into your working tree, and it would discard the work tree lines. Just the color scheme is not very good in this example. Checkout does a lot of things. You can do a lot of things with checkout. So in the first line here, we can check out our previous branch that we worked on. So we know now that Git tracks our project history using the log. It tracks our file history, but it also tracks our head history, or the history of which branch we just checked out. So using this at and a minus number, a negative number, that gives you the possibility to say, hey, check out the last branch I worked on, or check out the second to last branch I worked on. So you can, switch between branches that way. You don't have to remember which branch I was on, like previously. You can create a new branch. You probably all know this by using the -B option to check out. It just creates a new branch and checkouts and moves your head to the new branch directly. But you can also use the --orphan option, which would create a new branch that is disconnected from the rest of the history of your project. So it would be like you're starting a completely new project inside your already existing project, and you can create a separate history in that. And it's useful in some cases, let's say, for example, in GitHub Pages, if you're deploying a GitHub page, that's one of the ways that they provide you to do that. Detached head. So probably many of you have seen this, and a lot of people panic when they see detached head, which is bad. And usually it's bad, but in Git's not that bad. It just means it's just a scary name, meaning you're not on any branch right now. So if you git check out a branch, that would check out the commit, but your head would point to that branch. But if you check out a commit directly, that means that your head points directly to the commit and it's not on any branch. And in the picture, the only difference is, if you notice, is on the first line you have an arrow between head and A. So head is pointing to the A branch, but on the second example, head, comma A, meaning both of head and A are pointing to the same commit, but they're not related between themselves. So that's what a detached head means. We can move our head around. Once we detach it, it's kind of easier. So we can do it using git reset, and providing the --hard option would actually delete all the changes that you have currently in your working tree and in your index, and it would move your head, and it would make it point to the ref or the commit you designated in the command. This could make you lose your changes, so use that with care. Be very careful when you do that. Another option that you pass to reset is the --soft option, and you can use that to actually squash your commit, so you don't have to do the interactive rebase thing to actually squash. So if you do git reset --soft and provide a commit, it would keep all the changes that you have in your working tree and in your index, but would move your head back to the commit or branch that you specified, meaning that all the changes that you had between the branch you specified and your current point would be in your working tree, and you can recommit them, but you would create new history, so you will be rewriting history, basically. So if we don't want to rewrite history, but we need to change something in our, to revert some changes, we can use the revert command. And revert takes a commit and creates a commit that has the opposite effect of the original commit. So it would flip the meaning of the lines. If you added the line, it would remove it. If you remove the line, it would add it back. And that's pretty useful. Here we see that we want to, we did something bad in the X commit, and it's kind of a long time ago in our history. We can't, you know, reset it like that. So we need to revert it, and we create a new commit called revert X, which does exactly that. Moving a single commit around. So in Git, history is immutable. You cannot actually rewrite the history. You cannot change the content of a commit once it's created, and that would break security, and you don't want that. So the way to move a commit or to copy it is to use git cherry pick. So here we can see that we have a history, we have an O branch, an O commit. It branches off into A, B, and X, Y, and we want to move the B commit on top of the Y commit. So I can do that using cherry pick. So I say git cherry pick B. And if I'm on the Y commit at that point, it would copy the B commit and apply the changes on top of my current commit, so on top of Y. And that would be a completely new commit. If you look at the screenshot, if that's visible for you, you'll see that the SHA, the identifier of that commit, is different. It may have the same message, it may have the same changes inside of it, but the commit itself is a different object, basically. Moving many commits around, that's rebase, and it's one of the things that usually novices are really scared of. You shouldn't be scared of it. It's basically doing cherry picking on a whole branch. So in order, you cherry pick a bunch of commits. And there are a couple of ways to do a rebase. You can just do git rebase. You put the new base first, and then the commit you want to rebase, and it defaults to head. You can do an interactive rebase. I personally never do that for some reason. I don't know, don't like that. And my favorite is you can pull rebase, and usually I make a alias for that called gitup, which just does git pull rebase. And that would fetch the changes from the remote, and it would put your changes on top of the changes you fetched. So here it is in action. Here we had a branch, we had a commit O again, we had the AB lineage, we had a commit called W, which followed from O, and we wanted to move A and B on top of W. So we did git rebase W as the base, B as the target, and it created two new commits, A and B, which have the same content, the same changes as the original A and B commits, but are new commits on top of the W commit. So that's rebase in action. Setting up aliases. This is probably the most important thing I would like you to remember from this talk. Common tasks should be easy to perform. So you do great for yourself if you pick up a number of aliases that are easy for you, that make sense for you, and you can use in everyday tasks. Here I've put some of my favorites. So here I have checkout, which I abbreviate to CO. I do BR for verbose branching, and verbose branching gives you the name of the branch, gives you the commit that it points to, so both the SHA of the commit and the name of the change, and it also gives you some other information like the time and stuff like that, so you get more information out of the command. As I said, git up, which does the pull rebase thing, git LG, which is the option I use for logging. Actually, I use a slightly different command, which has some color codes in there for bash, so it's a little bit more visually pleasing, but this would basically do the trick for you anyway. And I have a quick fix alias as well, which basically amends a commit, so it adds some more stuff or actually creates a new commit that adds some stuff to already existing commit without editing the message. And I use -p, so I choose individual pieces of code I want to go into my next commit. And you can have a lot more aliases, and you can have global aliases, as I've shown here, but you can also have project-specific local aliases. So for, let's say, a particular project, you have a workflow that's not very good or kind of verbose, and you need to do a lot of stuff. That means that there is the possibility for you to create a local alias for that specific project that would help you resolve that situation and make your life easier. So fetching, comparing, and rebasing. So here, this is a common task that everybody knows and should be doing. This is how I usually pull my changes in. So I git fetch, giving in the remote name and the branch. I then compare the changes that I've just pulled in, comparing to my head or comparing to an appropriate branch. The left-right option would mark commits on the graph and designate which side of the split they're on. So if you remember that Y-shaped A, B type of situation, it would mark which is on the A side, which is on the B side. So it's more visual, and you understand better which commit came from where and what should I be doing now. And then finally, you can, after understanding and making sure that everything is in order, you can actually rebase your stuff on top of that or do whatever you need to be doing. You can push to save yourself from overriding commits by force pushing. Sometimes you need to force push some changes, but somebody might have pushed something, and so you override that and you lose changes. That's pretty bad. So you can use this push option, force with lease. What that does is it first checks the history of the remote. It checks if you have all the commits locally that are on the remote. So it forces you to fetch before you push, basically meaning, hey, you have to at least have all the commits that are on the remote before you force push anything, because otherwise you won't be able to restore the previous situation. So it makes your life a little bit safer. And I have an alias called SFP for that, safe force push. A couple words about resolving conflicts. So conflicts appear when Git cannot meaningfully merge the contents of two versions of your file. So whenever you're doing a merge, a rebase, a cherry pick, a revert, a lot of operations accept the -- abort option. That would cancel the operation you're currently doing, and it would bring back the same state of the repository that you originally started from. So let's say you're doing a rebase or a merge, and there are some conflicts that you cannot solve because you don't understand what the changes do. So you can abort that, continue working on something else, and come back to that once you have more experience or once somebody else can help you do that. I would suggest you not use the -- theirs and -- our flags. These are used inside merges and rebases, so you can indicate which version of a file you want to use in the new commit. So let's say you're pulling in some changes, and you can say, hey, both of you change this file. You can either go into the file and edit manually, fix the conflicts, or you can say, hey, use my version or use their version. But using these theirs and our flags it actually changes meaning between merge and rebase. So in merge, -- ours means the change I made, while in the rebase, -- ours would actually point to the change you pulled in from the other side, and that can be can lead to problems. So I suggest just put either the name of the branch or the name of the commit, the SHA of the commit there directly, so you don't get any ambiguity and you can just be more secure. So once you finish the resolving conflicts, you've added everything to your index, you can finish the operation using -- continue. And that's pretty common, of course. A couple words about common workflows that a lot of people have when using Git. So maybe a workflow that people kind of hate upon or feel that it's too simplistic is all in master. So a whole team working on a single branch. And for many teams, I found that they're overcomplicating their Git workflow needlessly. So they have many branches, they have many remotes, they're doing a lot of stuff that they don't actually need to be doing. And if you check their history, they have many merges that are just not necessary, and they could have simplified their workflow if they just worked on master. And there was nothing that was actually preventing them from doing that. So they didn't have any real constraints that forced them to not work in the same branch. Of course, you can branch off and have feature branches or team branches if you need to, if you have some long-lived change that you keep working on and you don't want to block everybody. Of course, you do that on a branch, but usually making the simplest possible workflow is the right solution. So you don't have to overcomplicate in advance, like premature optimization. Word about pull versus merge requests. So a merge request is a request that you make for somebody in your organization or in your team to merge that code in, to make you a code review, and then merge that code in. A pull request is the same thing, but if you have different remotes, so merge requests would be in the same remote, and pull requests would be across different remotes. In terms of, this is just an administrative difference, so in terms of Git operations, they're completely the same. And merge and pull requests are not actually a Git thing. They're just kind of an email you send to somebody, hey, this is my branch, can you please look it up and merge it if it's good. So, yeah. There are a couple of techniques you can use to keep your history clean. One of them is merge without a fast forward. So here we see we do a Git rebase. We rebase our feature branch on top of master, and then instead of just pushing that, instead of just fast forwarding, we do Git merge the feature branch inside of master, but we specify no FF, which means no fast forward. What that would do, it would keep all the commits that were on your feature branch in a separate lineage in your graph. But there will be no other commits on the other side of that lineage. So it would be a very good visual indication that, hey, these commits all happened on a branch, these are related, and they are all part of this feature. And when you look at the history later on, it's pretty pleasing and visually easy to understand. If you don't want to do that, if you have too many commits, and you don't want your history to be too fat, then you can kind of achieve the same thing using a tag and squash approach. So here we finish our work on a feature branch, we tag that with a local tag or a simple annotation tag, just saying, hey, feature branch is done, and then we squash and we merge the squashed commit inside of master, but then we also have the original commit lineage under the tag, so we can go back to the original state of the code in the feature branch and have some that if we need it. So some recap and takeaways. Use the console. That would definitely make you more productive, in my opinion, and help you understand the internals and the mechanics of Git better. Name remotes, branches, and commits meaningfully. Keep a format and have it consistent within a team. Keep your workflow and history understandable. They should be your tools. They should help you do your job better, especially the history. You can look at it and you have to appreciate that, what's happening and be able to understand it better. Fetch and push often, of course. And most importantly, read the manual, because that's where you discover things that you didn't know and it would make you more productive. And of course, make Git help you. Yeah, here are some links that I recommend you checking out if you're interested. Any questions?
Hi. Thank you for the presentation. I want to ask you about something about the workflows. You said not overcomplicating the workflow, but one of the advised approaches is Git flow. I guess you are familiar with this, but for me it's really complex. So what's your opinion about Git flow and where is appropriate?
Well, so there are so many different techniques, and Git flow is one of them, and it probably will take me a long time to just describe it. But Git flow is exactly, it's a very complicated workflow. And as far as I know, it came out of the kernel development process, and they have a very large community of developers with a lot of different responsibilities and a lot of different tracks of changes and many different concerns. So in a great big organization, in a code base that's millions of lines of code stretching back to the 90s in terms of history, maybe that makes more sense. But in terms of you being a startup or being a small agile team within a larger organization, you know, you don't have to. You just basically use the features that make sense and that help you do your job. Don't just use features for the sake of it, would be my advice, if I answered.
We have like 8 more minutes for questions.
Woohoo! I have some more slides if I was too fast. Sorry.
Yeah, Micho, so I want to ask you, is there a way in GitHub, particularly, to make some kind of pipeline where whenever you make a commit or a push, some scripts run and they test if the build was successful?
Sorry, in GitLab?
GitHub.
Oh, in GitHub. Yeah, definitely. There are, in almost all the popular visual Git tools, there are ways to attach what's called continuous integration services. And we can talk about that later. But for example, Travis is a pretty cool open source and free to use continuous integration service that you can very easily attach to your Git repository, and you can configure it to follow your branches and to check them out and run tests and all that. So you get that, yeah.
Okay, cool, thanks. And another one. I noticed that you prefer using rebase and merge instead of pull. What's the benefit of using that instead of directly pulling?
Yeah, for me, the benefit is the ability to stop and introspect about what I just pulled does, right? So I can fetch, I can see how many commits are there, who made them, when, why. I can, look at them, just, visually verify if the code looks okay to me, run the tests on that branch before merging my stuff in. So that gives me that sort of peace of mind, and, seems just better for me to not bunch the merging and the pulling together. It just doesn't make sense.
Yeah. Thanks.
More questions? Yeah.
Misho, hi.
Hi.
In a typical continuous integration scenario, what is the easiest way with Git, and probably with less tools, to implement branch-based permissions, just so someone accidentally doesn't commit into a continuous integration link branch and automatically deploys to dev and UAT? What's the easiest way to do it?
Sorry, I didn't catch the...
Okay,
what?
Continuous integration, pulling off a branch. Let's just call it a dev branch, okay?
Okay.
How can you prevent other developers from committing or merging into that branch in the easiest possible way?
Well, okay, so, there are, for example, popular things like GitLab and GitHub have branch protection mechanisms that you can use for that. The other way is using hooks. So here in the extra slides, I have a good picture that shows what a hook is. So once you push, there is a pre-receive hook that you can use, and it receives the commit. So before the commit is actually considered to be received by the remote repository, this code is run, this hook is run, and you can say, hey, you can do any kind of check within this hook and reject the push if you're not happy with this. So basically, that's kind of the easiest way.
When talking about Git workflows, one of the most common points of discussion and point of war sometimes is using merge versus rebase for getting stuff into master. What's your take?
My opinion is that each team should make an educated decision about what their workflow should be like. So it depends both on the personalities within the team, on the project itself, so what kind of code it is, how it is changing, what's your expectations. So I don't think there is a single best way to do this. Rebase gives you a more linear view of history. Merges tell you more detailed, like who did what when. So it depends on what you want to see, how experienced are the people on your team. So one reason not to use rebase maybe is that you're all juniors and nobody has in the team has good knowledge about Git. You're all kind of getting started. So you lose more time just by trying to do it, and will probably make more mistakes. So in the beginning, you start with the simpler thing and then do that. Maybe, but I don't think there is a clear winner between a merge and a rebase. They both have their place in the workflow.
Hello. While I certainly appreciate the power of the command line, there are a few things I don't particularly like, and I would like to do them via graphical interface. Namely, that would be differencing tool and merging tool. So like instead of git diff and git merge, I would be using diff tool and merge tool. You have any recommendations of something that has worked very well for you, or you are the purely console guy?
No, I'm not a purist. So yeah, what I said in the slides is it's a symptom of Git panic if you only use Git through the GUI. So I definitely see places where the GUI is very useful and it can be very good. Even in exploring the history, so doing a graph of the history can be better visualized through a GUI, and it's much more easier to click around and see stuff. As well for conflicts and just diffing. I don't have a particular favorite tool. It also depends on what kind of programming language you're in, so there are a lot of specifics. Right now I think I'm mostly using Atom and VS Code, and I don't think that both of these tools, I mean, for me at least, I revert back to the console because I the mental overhead for me personally is bigger to try and figure out how the interface works than using the console. But I don't say never use those, right? So sorry for not being able to offer a good suggestion.
Okay, so we have time for one more question. Last question? No one? Okay, so please applaud the lecture.